Hello, my name is Nick Parenti, and I'm with the Mendoza College of Business at the University of Notre Dame. And I'm here to talk to you today about measuring the value and impact of science and engineering research enterprises. Before moving on to discuss ideas of measurement and measurement of value and impact, let's talk about the notion of value. This particular painting, if someone were to bring it to me and say you could put this up in your family room, I wouldn't be too thrilled with it. I would look at this painting and think it doesn't match my house. It's a very little value to me. I wouldn't be very taken with it. But apparently someone found it valuable. This is Mark Rothko's number 6, and it sold almost a decade ago now for about $180 million. So clearly to somebody it was valuable. And that's an important point about value. Value is in the eye of the beholder. The same thing is valuable to different people in different ways, and different folks find different things valuable. And when we think of those different people of your science and engineering research enterprise, those are stakeholders. And the value that your enterprise brings is the benefit from the perspective of that stakeholder. And in general, it means you solve that stakeholder's problem or you satisfy one of the needs of that stakeholder. In order to communicate value, we all want to talk. We want to let people know what value we bring them. But before we can communicate what value we bring to people or what we offer to people, we need to understand what value we bring. And in order to communicate, we need to understand. And in order to understand, we typically need to measure. And that's what I'm going to talk to you about here today. This is Lucy. Lucy's a scientist, and she has her own research lab, and she has a team, and the team that she works with finds certain things valuable. But then Lucy, her team is embedded in a set of other teams at her university, their funding agencies, their local government, industry partners. And these are stakeholders outside of her team. She has stakeholders within her team. She has stakeholders outside of her team. And what's really interesting is that what she and her team value is typically not what the external stakeholders value. One way to think about this, for those of you familiar with kind of traditional evaluation techniques, is to think in terms of her research and enterprises as in terms of a logic model. It's an input process output model. There are the elements that go in to her research, how she does her research, and then of course the outputs. And if you look at these outputs, you can partition them. You can think about 2 types of outputs. One is outcomes and one is impacts. Now, granted, these are formulated different ways depending on which version of the logic model you're looking at, but we found this one useful. And if you look at the outputs and you distinguish between outcomes and impacts, you might find that one way to look at it is that the outcomes, the very specific, the proximal outcomes of the research are what Lucy and her team values. Whereas the impacts, the distal, the outcomes on other people's activity, on other activities, are what the external stakeholders value. And oftentimes, what you value is not what your external stakeholders value. So I've done a lot of work with, for example, high performance computing centers and HPC centers. This is what they value. They value, number of cores, how much memory per core, memory allowed per job, the performance. What exactly are they doing? How efficient do they operate? How well do they perform? These are the types of things that folks who run HPC centers are interested in. However, if we go to their external stakeholders, say the National Science Foundation, the National Science Foundation is not interested so much. There are people at NSF who are interested certainly in efficiency and operations of their HPC centers. But for the most part, they're more interested in how much science is advanced because of these HPC centers. How many publications and findings are they contributing to, right? Their university's CFO might not be interested in this, but they might be interested on the return on investment, cost per unit of performance. And then maybe their regional and their state government is not interested at all in their performance or even their science findings, but maybe they'd be interested in their workforce and workforce development, the impact that they've had on the local economy, perhaps in terms of startups created, funding that they're able to generate and that sort of thing. So the external stakeholders tend to have a different set of things that they find valuable. And that's how you want to think about measuring the impacts. Are those impacts to your external stakeholders? Outcomes, we found over the years, science teams are pretty good at understanding because it's what's valuable to them and their team and their internal stakeholders. The external stakeholders, demonstrating value, understanding and communicating the value, comes down to understanding and demonstrating the impacts that you have on those other stakeholders. So you want to think about it from the external stakeholders' point of view when you're thinking about impacts. And we've done a lot of research in this area, and we've decided that there are 4 dimensions of impact. Now, you can argue, and those have, that maybe there are more dimensions. Maybe there's some of these are not as mutually exclusive as you might think, but we found these to be 4 very useful dimensions. And we find them to be collectively exhaustive and close enough to mutually exclusive. But they're here to help you think, the 4 dimensions of impact. And the first is your actual science and engineering outcomes. These are oftentimes your internal stakeholders, your team is very concerned with this. They might not do as well to measure that impact, but oftentimes they do a nice job. As far as the economic dimension of impact, that's dollars. Workforce, these are the students, the people who go through your enterprise and then move on to do other wonderful things in the world. And then finally, innovations. These are the artifacts, the things that your enterprise creates. And you can think in terms of measurements for each of these. And we have many different lists and many different perspectives. These are not by any means exhaustive, but these are ways that people think about measuring, say, their science and engineering output productivity, right? When you think in terms of measuring economic, oftentimes there's grant revenue is one way to think of economic output, but then there's also other ways of thinking about it, say to your external stakeholder, like a funder, maybe your university's matching funds. There are other economic issues such as complementarities and spillovers. And if you think complementarities, these are the things that come because you got your funding, and spillovers are, you can think in terms of those economic returns that were a result, an indirect result of gaining some economic resources. And because of complementarities and spillovers, oftentimes people think federal funding will have 140 to 196 is usually the multiplier that I've seen economists use. For every dollar you get, you can add another 40 to 96% onto that dollar because of complementarities and spillovers that you can expect in terms of multipliers for those federal dollars that come to a local state. So workforce, you can think of some measurements of workforce, think of ways to think about how you're building capacity for your stakeholders, maybe upskilling the workforce, so building capacity for skills that are in demand, or upskilling, creating new skills that didn't exist before in industry. And then, of course, there are a lot of stakeholders very much concerned with generating workforce capital in underrepresented groups and giving underrepresented groups significant opportunities that maybe they haven't had in the past. And then finally, we have innovation. You can think of kind of the indirect outcomes of your science and engineering products. And this is, of course, patents, but also startups. And you can think of different ways to measure startups, and not just startup organizations, but entire new industries. And if you've never seen NSF's tire track diagram about the new industries that NSF funding in the 70s and 80s kind of created, it's really interesting. And then, of course, new technologies, tech transfer. These are a number of different ways to think through the different dimensions that your science and engineering research enterprise may impact external stakeholders. But again, it's not an exhaustive list. We can't give you an exhaustive list. You need to find how to measure, how to understand and to communicate your dimensions of impact for the stakeholders that matter for you. So what we generally suggest, and we do this with organizations, my collaborators and I, we think through those dimensions of impact with a particular enterprise, and we think through their stakeholders, their important internal and external stakeholders, particularly external if we're talking about demonstrating impact. And what we'll do is we'll think through from each stakeholder's perspective, what are they interested in? If they're a state government, maybe they're just interested in, say, our workforce. And maybe if they're the National Science Foundation, maybe they're interested in a number of things, maybe all four. So we want to think through what it is they're interested in. And then we want to figure out a way to understand that, figure out a way to measure it so that we can communicate it. And the way, of course, we do that is with metrics. So we're going to go over a little bit on kind of the basics of metrics. And a metric is a specific measurement through which we can evaluate performance, right? And this is the basic idea about metrics, is that it's got to be specific and it has to be measurable. So you describe exactly what you're doing and then come up with a number for it. And there are some keys to reporting and to thinking about metrics. And the main key that I like to argue for is to provide context around each metric that you construct. So for example, we have this result, this measurement. We found that, say, in a given year, we did 10 publications out of our enterprise. My question to you is that good? Well, you don't know until we provide context. And what if that context was, well, our goal was 8 publications? Well, if our goal was 8 publications, then by all means, 10 publications was pretty good. Our benchmark, if typically organizations, enterprises the size of ours get around 6 pubs a year, then 10 publications is pretty good. Trends, right? We look historically. What did we do last year? What did we do the year before? We can show a trend. And then the other thing is markers of quality. Perhaps 10 publications, whether that's good or bad, is irrelevant. What matters is that 2 of those were in Nature, and that all of a sudden, if we have 2 in Nature, now we understand that we're doing good work. So that's the one key when thinking through metrics. Not only do they have to be specific and measurable, but in order to understand them and report them, you need to work with some sort of context, and set the context around those metrics. And that context could be targets, benchmarks, trends over time, and some sort of qualitative understanding of the metric. There are different metrics for different elements of your enterprise. Hopefully, all of your enterprises have a vision, which is your aspirational goal, your mission, which is a statement of what you do. And of course, if you're going to ever make a statement about what you do, implied in that statement is what you don't do. So that's your vision and mission, your aspirational statement, and then your vision is, if everything goes well, all right, this is what will happen. Your mission is, okay, this is what we do. And then your mission, you break up into high-level strategic goals. Since this is what we do in our mission, these are the 3 things we need to do to accomplish that, the 5 things we need to do. And you roll up very high-level metrics to address those strategic goals, and we call those high-level metrics key performance indicators. Each enterprise will only have a relatively few key performance indicators. These are the main signals that let us know how we're doing to our main goals. But these aren't the only goals we have. We have a number of objectives. We can break those goals down into more specific objectives. And these specific objectives can be both impacts and outcomes. They could be things that are internal stakeholders, and we need a metric for each one. We need some way of understanding how we're doing in each one. So that means we need to measure it. And then we can communicate it as well. And then finally, there are their activities. Now, these aren't the goals. They're not the outcomes. These are the things we do. And typically, when you think of activities, the activities will hopefully result in achieving your objectives. But oftentimes, if we have things like deliverables and milestones and other project management sorts of outcomes, we would put those down in activities. And in general, measuring our activities is not the same thing as measuring our progress on objectives. So what form do we communicate? Well, there are 4 general forms that we can communicate metrics and how we can understand and communicate, the value that we're providing, both internal and external stakeholders. The first is, of course, quantitative. And when we think metrics, people usually think in terms of some sort of numeric, quantitative, but there are also qualitative metrics. These are oftentimes categorical. as I mentioned before, publishing a paper in Nature is perhaps a different category of journal than the journals I would say normally publish in. So if I were to publish in the Journal of Nature, that's a qualitatively different. So usually with our metrics, we try to capture some quantity. How many Nature papers did you publish, or how many papers overall? And then something around quality. How many of those were in, say, very prestigious outlets, right? Another thing we have oftentimes when communicating metrics, we want to communicate visualizations. And, visualizations are particularly good when we want to express things like trends, when we want to compare more than one thing to something else, and certainly when we want to show proportions. So temporal trends, proportions, that sort of thing. And then finally, and we cannot underestimate the stories and the testimonials. Now, stories and testimonials are particularly memorable, right? A lot of times metrics are not as memorable as a good story, not as evocative. And oftentimes also your metrics will do things like list central tendencies, whereas sometimes the outliers are really where a lot of the impact, a lot of the value that your organization provides. So don't underestimate the power of stories or testimonials. And we'll talk about each. Examples of, I would say quantitative metrics, they're all over. And here I'll give you a citation, and we're publishing these slides. Here's a link to something we did, for example, with financial ROI of cyber infrastructure enterprises, right? I do a lot of work with cyber infrastructure and HPC, as well as other large scale enterprises. And we looked at financial returns on investment. You may not see everything here in this slide, but you might want to download this. The bottom line is there are a whole bunch of different kind of quantitative measures of financial ROI on these projects. But we also did another project, and this is a different article. A lot of the same people did, where we looked at non-financial impact. So we looked at some of the things in the other three dimensions that we just mentioned. Not so much science, but a little bit more around workforce, a little bit more around innovation. And the other thing we did is we showed a nice visualization. We showed a chart showing essentially how tying the resources to the outcomes of those resources. And a really, sometimes, and it's in that same article, sometimes a nice visualization tells the story of those metrics quite well. It demonstrates that. Another project we did, we looked at, and this was as a way of measuring the workforce. NCSA is the National Center for Supercomputing Applications at the University of Illinois. And we worked with them to look at what we called their diaspora, which is the graduating and the people who came up through NCSA and where they went, going off of the metaphor of ethnic diasporas as they go from their originating country to other nations. And we looked at NCSA's diaspora, and we found that they sent a lot of people. If you look at the image on the right, that big gray area was they went to Illinois. And we really made the strong case that look at the impact they're having on upskilling the capabilities of organizations in Illinois. And of course, the second biggest was California, but Illinois was significantly greater than California, as you can see here. And then we helped show relative proportions of where they're sending, where they're graduating their people. And you could see that, the bulk were in academia, but after that, a lot of those businesses like software, web and mobile tech. And then if you look at the organizations I went to, Caterpillar was a big one, but outside of that, you had Google, Microsoft, a lot of the other organizations. So these are some ways that you not only get those metrics, but you want to, in order to communicate value, you need to show, it would make sense to show some visualizations. And then the final thing that I want to talk to you about as far as communicating the impact of your science enterprises are science stories. And if you go to National Science Foundation, they actually do a pretty nice job of this, and on their website, where they tell a story. And remember, there's some rules to telling a story. The first rule in telling your story is to connect with your audience. Any good author knows that they're writing for a particular audience demographic. Know who, are you writing to scientists? Are you writing to lawmakers? Are you writing to the general public? So know who you're writing it for, which stakeholder group you're writing it for. And then you need a protagonist. Okay, so maybe we look at new developments in quantum computing, right? Who's the protagonist? Well, maybe it's those quantum scientists trying to figure out the next step in quantum computing, for example. And so that's the first thing. Every story needs a protagonist, but then every story also needs a challenge. What is it they're facing? What is the problem? What is the adversity? What's the issue that they're facing? Give context to the issue. Why does the issue matter? After you have a protagonist running into an issue and you give a lot of context around the issue, then you bring it to a resolution. What happened? What's the outcome? Why does it matter? Those are the components of a story. And stories, again, are wonderful. They're wonderful for a variety of reasons. In part, they're memorable. They help explain causal relationships. You might use metrics to identify outcomes, but this will give you the mechanisms for where those outcomes came about. And as I mentioned before, the outliers, right? The special cases. And then the last thing I'd like to tell you about science stories is that it's incredibly important for them to be credible and authentic. You cannot, this isn't smoke and mirrors. It's not a sales job. Yes, it's a protagonist facing a challenge, resolving the situation, but it has to be authentic. It has to be real. With that said, I would like to direct you to some of my collaborators and I, Joel Kutcher-Gershenfeld at Brandeis University, Susan Winter at University of Maryland, and John Leslie King at the University of Michigan, and I, for a number of years, have been working with a variety of, I guess more than a decade now, with a variety of science enterprises, science and engineering research enterprises of all sorts. And earlier this year, we did a workshop for the National Science Foundation called Leap to Large. And the idea was to have principal investigators that have gotten grants. We were working with the SIZE directorate of NSF and those that have gotten grants. And we talked to them about what's the difference between a small grant and moving on to a big grant. And here you see, if you go to YouTube and just put in Leap to Large, you'll go there. I strongly suggest you look at our introductory, our explainer videos first. Those are about 2 to 3 minutes each, because the workshops themselves are also online on YouTube, but they are at least 90 minutes each. So before you commit to watching a 90-minute workshop, you might look at the explainer video for that particular workshop. And we have a series of 7 of these workshops, and these are the topics of those workshops. And there's your link. And I look forward to continuing our conversation. Thank you.